projection box equipment and measuring the time in which the sun drifts across one diameter of the projected disk, the angular diameter of the sun can be estimated. One needs to draw a circle with diameter equal to the diameter of the projected image of the sun. This can be done by marking 3 points on the circumference of the projected image. You will need to mark all 3 points very quickly. Else, the diurnal movement of the sun in the sky will be manifested in the projected image to your discomfort, spoiling the accuracy with which you can estimate the diameter of the projected image. Once you have the 3 points marked, draw a triangle through these points. Draw perpendicular bisectors of all 3 sides. They should meet at a point. Measure the distance from this point to each of the vertices of the triangle and average this value. This will be the radius of your required circle. Draw the circle, insert it in the projection box and check whether the drawn circle fits the projected disk of the sun exactly. If not, you may need to iteratively adjust the radius of the circle you draw until it fits the projected disk well. Once the circle is drawn to satisfaction, insert a fresh sheet with this drawn circle back in the projection box. Let the sun drift exactly into the drawn circle. Start your stop clock or time counter at that time. Stop the time counter when the sun just drifts out of the drawn circle. All this while keeping the projection box at the same position. Note down the time difference t in seconds. Once you have got this time difference t, what you need to do is just use simple ratios, taking for the fact that in 24 hours sun is making an angle of 360 degrees, and so the time delta t that we have in which sun is drifting by one of its own angular diameters can then be used to measure the angular diameter of the sun. And here are some results by students, and there is the theoretical value obtained for the date of the observation from calsky.com, and these are values that students have obtained. So one can see that very good accuracies are possible with this projection equipment, and here is where students have made this. We can see that the size of the projected disk of the sun that you have here, that's the kind of size that we obtain. Well, of course, these are obtained with international galileoscopes with these long projection boxes. And so we got directly in the very first broadcast, we got into using projection boxes for some quantitative measurements. Here it was a measurement of the angular diameter of the sun, which can be done at any time, but on the day of the transit, do it after the transit is over. And during the transit, we image the sun with Venus on its disk, print it on a graph sheet or something, count the number of millimeter squares occupied by Venus and the number occupied by sun, so we can obtain a relative measure of the angular diameter of sun and Venus, which is what we need. But with this method, we can also obtain the absolute value of both of them. So this is one small activity which can be done. Of course, we are going to go ahead and talk about the main observations which we want to do, which are the contact timings and how the transit of Venus is going to be used for measuring the astronomical unit, some interesting history and so on, which will be discussed in the following segments.